I work as an experimental particle physicist.
I do research on astronomical instrumentations.
I'm doing research in neutrino physics.
Atomic, molecular, and optical physics, or AMO.
Theory again on quantum optics.
I'm a particle physicist.
I try to break matter apart and keep zooming in increasingly into smaller and smaller and smaller scales.
To try and understand how the universe was created and what its constituent particles are. I have a 3-minute thesis speech video I can just give you instead.
No, that was great. That was great.
This is so good.
My second year in college, I went to this conference for undergraduate women in physics, and I saw the different research opportunities that were available if you were a physicist, like from doing biophysics and studying like a heart system, or why does a heart go into an arrhythmia, or like being able to trap ions or trap atoms and doing quantum computing. And I was just amazed by all the possibilities that all the things you can work on as a physicist.
What I like most about research is that it's never the same. There's all sorts of problems that come up, interesting problems, mind-boggling problems that you have to think about how to solve, and there's a lot of room in that sense for creativity, and I think that's the thing that I love the most about research in my field.
And I like to think as physics as the liberal arts degree inside science.
I've always really liked science, but when I got to university, I started getting into physics a lot more, and I realized that I really liked the types of questions that were being asked and the scope of those questions. And I think the biggest thing for me was that it was a humbling experience to realize how small I was compared to the vastness of the universe, and I really liked that feeling.
And I really like the predictive power. So I really like how the math combined with physics and how it could, I could ask questions and answer them.
But the thing that attracted me to physics over other fields of science is the ability to use mathematical relationships to break down the universe into simple equations from which you can derive complex phenomena.
I really wanted to understand why the world was the way it was versus how to apply the knowledge that we had to something else.
And what I like about it is when I actually think about what we can do and what is the optimized way of looking at the problems. And basically, in general, I can say problem solving is very interesting.
Also, there is, I should mention this, physics is not immune to societal differences. So the differences in society creep into physics as well, actually in a big way, if you look at the current culture of physics. So for a lot of the women and other minorities who are trying to get into physics, at least you lack a sense of encouragement from both inside the home and outside. So it's actually leading to many women and other people dropping out of physics. So to me, I would say is, if you see a role model, if you're inspired, just go ahead and try to do physics.
I think anyone who has a sense of wonder belongs in physics, and specifically fundamental physics research. Studying nature, how it comes about, our universe, what it's made of, what is dark matter, can we time travel? Okay, those are a little extremes. But,
My name is Iris. I'm from Honduras.
My name is Emily. I'm from Montreal.
I'm Guanqing. I'm from China.
My name is Barbara. I'm from Brazil.
My name is Elena. I'm from the Boston area, and I'm a physicist.
And I'm a physicist.
And I'm a physicist.
I'm a physicist.
And I'm a physicist.